Everyone, today we're going to be talking about factoring expressions by using the greatest common factor. So if you see, the topic of today's lesson is the distributive property and factoring expressions. If we look at this problem, it says how much would it cost to buy the clothing shown if each t-shirt costs $20 and each pair of jeans is $25? Write an expression to represent this. Can you think of a second expression? So we're going to talk about a few different expressions to represent this. So right now I know that a t-shirt is equal to $20. I also know that the jeans are equal to $25. So if I'm going to write an expression to model this, I see that I have 3 shirts and I have 3 pairs of jeans. So one expression could be to just write everything out in expanded form. 20 plus 20 plus 20 for each of the t-shirts, plus 25 plus 25 plus 25 for each of the jeans. And I would get a total of $135. A second way I could write this is, since I have 3 t-shirts, I can do 3 times 20 and 3 jeans plus 3 times 25, which also equals $135. A third expression could be, since I have 3 of each item, I can have a 3 on the outside, and on the inside of my parentheses I would add 20 plus 25. So if I simplify this, I have 3 times 45, which is also equal to $135. So those are 3 different ways that I can write this expression. If I go back and again just look at number 2, if I want to simplify that, 3 times 20 gives me 60, plus 3 times 25 is 75, and that's how I got $135. Okay, so modeling with mathematics. How can you break up your tiles into even groups? So right now I'm given this expression, 2x squared plus 6x plus 8. So I see it's modeled below. 2 of the x squareds is the green tiles. I have 6 blue tiles and I have 8 smaller tiles. So if I want to break it up into even groups, I'm going to see how I could split this between the 2 boxes. So I'm just going to draw the tiles. So I see that I have 2x squared. So what I can do is put an x squared here and an x squared there. So that uses both of my x squareds. I have 6 x's. So if I want to break those into even groups, I would have 3 x's in each group. Lastly, I have to break up my tiles, my positive tiles. So I have 8 yellow squares. I'm going to break that up into 4 and 4. So now when I'm looking at my tiles, I was able to break my tiles up into 2 even groups. How can you write an equivalent expression to represent how you broke up your tiles? Well, if I want to write an equivalent expression, I have x squared plus 3x plus 4. I also have x squared plus 3x plus 4. So this expression represents what I did with my tiles. Because I have 2 groups, I can write 2 times x squared plus 3x plus 4. 4. And if I wanted to check this, I would use the distributive property to expand this out. 2x squared plus 6x plus 8. And I see that I get my original expression. Then it says, in words, write down what this means. So what did we just model with these tiles? What this means is that we have two groups of x squared plus 3x plus 4. So when you're talking about the distributive property, the number on the outside tells you how many groups you have of whatever is on the inside of the parentheses. So if I look at this one, using your prior knowledge of the distributive property and algebra tiles, simplify the following expression. So you see that it's modeled below, right? So if we discuss what we just spoke about, we have 4 groups of x plus 6. And if I model this with the distributive property, 4 times x is 4x, 4 times 6 is a positive 24. So I'm left with 4x plus 24. If I count the tiles I have below, 1x, 2x, 3x, 4x, and I have 6 positive tiles in 4 groups, which represents the positive 24. So in this picture, you visually see how we can represent this using algebra tiles, and here you saw how we can do it mathematically.